Thursday, July 17th, 2020. July 16, 2020. Sorry about that. We are pleased to have you here with us this morning. We have a wonderful presentation provided by our friend Janelle from West Basin Municipal Water District, and she has a great presentation and a lot of information to provide you. So make sure that you ask lots of questions. Okay, Janelle, we're going to go ahead and allow you to present your wonderful presentation. Thank you.
Great. Thank you so much, Mr. Baez. So today we're going to be helping you answer the question from one of your units, which is how can East Ferris turn wastewater into clean, fresh water? So let's go on with an overview of our presentation. First, we're going to introduce you to the concepts of cleaning wastewater, and then we're going to show you a video of the facility that I work at, which is the Edward C. Little Water Recycling Facility. And I'm going to show you a fun water filtration activity that you can all do at home after this lesson today. So by the end of today's presentation, you will all be able to establish foundational concepts or be able to understand wastewater treatment and cleaning. So today is going to be a lot of cool stuff. I'm going to show you some membranes and some chemicals that we add to our water, and I want you all to just pay attention and get really engaged. I love questions. So we're going to start off with our introduction. So I have a question for you. How can dinosaur pee turn into our tap water? So this is something that I'm telling you is actually correct. Our dinosaur or our tap water could even have been dinosaur pee a long time ago, but dinosaurs were around 65 million years ago. That's a lot older than you, me, or everyone in this room combined. They lived on islands like Ferris, on the continent of Pangaea maybe, and everywhere around the world. And even though they lived so long ago, we all have something in common with dinosaurs. They needed to breathe, they needed to eat, they needed to drink. And after you eat and drink, things happen, such as pooping and peeing. So even the dinosaurs needed water back then, and what goes in must come out, and it comes out as pee. So all of the water we have on Earth is the same water that we had 65 million years ago. That we can't actually make more water. We all are just left with the same amount of water 65 million years ago, and we'll have the same amount of water in 65 million more years. So all of that water on our planet Earth is contained in plant leaves, in the ocean, in lakes, in rivers, in the air, and in our bodies, and in even poop and pee. So remember, what goes in must comes out. But how do we have enough water for all of us if we can't create more water? So the answer to that question and to the dinosaur question is the water cycle. So all of you should have been familiar with the water cycle. I think you all are fifth graders now, and the water cycle is something you learn in third grade. So there's evaporation, there's condensation where the water vapor gathers into clouds, and precipitation when it comes down as rain. And all of that water, when it comes down in rain, it collects or accumulates in lakes and rivers and the ocean. So Mother Nature's water cycle is basically nature's way of cleaning dirty water or cleaning water. And through the water cycle, water goes from wastewater to clean fresh water, or from fresh water to salt water. It just changes through the cycle. And that's how that dinosaur pee could have ended up through the water cycle in our tap water. All of our water, again, is the same water from 65 million years ago. And remember, the kind of water that all of us use is actually just fresh water. So we're going to be learning how we can help protect our freshwater resources, especially on Ferris. So I'm going to go over to this image right over here, which is called the urban water cycle. It's different than Mother Nature's water cycle because it shows how water comes to our homes and then how it leaves after we flush the toilet when we poop and pee. So a lot of our water comes from, for example, there's a dam. If you live in Southern California, we actually import water from hundreds of miles away and we store it in dams. So after the dams, it gets cleaned before it gets sent to our homes. That's the type of water that we use to shower. That's the type of water that we use to drink. same type of water that we brush our teeth with, flush our poop and pee down the toilet with. But after we're done using it, it has to go somewhere. Now, most places send that dirty water to a wastewater treatment plant where they clean all the junk out of it. They take out the poop, they take out the pee, they take out the toilet paper. Maybe someone flushed a dead fish down the toilet. They take all of that stuff out and they either clean it enough to release back into the ocean, or they clean it enough to reuse in our communities, such as for watering the grass at your parks, maybe flushing toilets, or helping in refineries such as the ones that we have here in Southern California. So again, I work for West Basin Municipal Water District, and we operate a facility in El Segundo which takes wastewater and turns it into cleaner, recycled water. So this is the type of water that we can reuse in our communities, such as flushing our toilets, just like I said, or if you see a purple sign like this one at the bottom right-hand corner of this screen, that means that a park or some field is being watered with recycled water. Or we can also reuse it in the upper right-hand corner, which is just another refinery. So there's lots of different ways that we can take dirty water and clean it again, and then find different ways that we can use that cleaner water to help save the small amount of fresh water that we have. So basically, we clean dirty water so that we can reuse it in our communities and save drinking quality water. We're basically copying Mother Nature's water cycle, which I showed you earlier, and we do it really, really fast. At our facility, our whole process actually takes under an hour. So now we have a challenge. Remember, the question that I posed to you in the beginning of this lesson was, how can we turn this dirty, icky water into this clean tap water? So again, what does the left image make you feel? Like, what does it make you feel good? What does it make you think about? What questions do you have about it? And then alternatively, what does the right image make you feel? What does it make you think? What does it remind you of? And what does it make you feel? So that was the end of our introduction. Mr. Baez, do we have any questions?
Well, we do have a question from Delilah from San Antonio. And I know you showed an image, Janelle, about using recycled water to use it on plants. But can we drink that recycled water? This is what Delilah wants to know. Can we drink the recycled water, and can we feed it, and can we give it to our dogs, or like dogs and our cats? Can we give them water? That water?
That is a great question, Delilah. So it's a little bit complicated. The type of at my facility, or at the Edward C. Little Water Recycling Facility that I work at, we create 5 different types of recycled water, and they're all for different uses. Now, the cleanest type of water that we produce meets drinking quality standards. So yes, it is clean enough to drink. And if you visit us at our facility, we have a permit to allow students to take a sample of it in a small little cup. But right now, as it is, it's not legally allowed for people to drink recycled water at their homes. So that's a great question, Delilah. I guess it's a complicated answer. Yes, there is a way to make recycled water that is clean enough to drink, but right now the current laws and regulations do not allow us to. Next question. Any more questions?
As of right now, no.
Okay, so great. So I'm going to continue on to our next section, and we're going to get a mini tour of our Edward C. Little Water Recycling Facility. Again, like I mentioned earlier, we make 5 different types of recycled water. So we're going to see how that recycled water is made. At our specific facility, we clean 40 million gallons of water on a daily basis. So that's a lot of water. If you want to visualize how much water that is equivalent to 60 Olympic-sized swimming pool. So many of us haven't even seen an Olympic-sized swimming pool in our lives, because an Olympic-sized swimming pool is actually bigger than the swimming pools at your local plunge, or at local pools, or at your apartments building. So it's enough water to fill 60 Olympic-sized swimming pools, and we clean that amount of water on a daily basis. So moving on, this is just a snapshot of our water recycling process. So we use a combination of some chemicals. We also use some membrane filters to clean the water. And on the right, you can see, again, like I mentioned earlier, we make 5 different types of recycled water. And we have different uses for those different types of water. So there's one type of water that we make, which is used just for watering plants. And the cleanest type of water is a type of water that we use to protect the ocean, or protect our groundwater from being contaminated by ocean water. So again, there's lots of different uses for recycled water, and we all clean them to different qualities or different grades so that it matches that use. So to give you a bit more information about how we recycle water, I'm going to be showing you all a video of a tour of our facility. Mr. Baez, I'm gonna play the video, but if students can't hear it, just let me know and we'll figure it out. Oops. And there we go.
I needed this. We all need this. Drinking water is crucial to our daily survival.
So why do we flush our toilets with it? Wash our cars and our sidewalks with it? Did you know that half the water in an average household goes to watering outdoor plants? And industry uses a lot of water in steam generators, cooling towers, and all kinds of industrial processes. Wouldn't it be great if we used recycled water for at least some of this stuff? Well, we can, and we do. Welcome to the West Basin Municipal Water District's Edward C. Little Water Recycling Facility in El Segundo, California. This one-of-a-kind water recycling plant produces designer water for irrigation, commercial, and industrial uses, and even groundwater protection, all in one location. It's a really cool process. The water starts out as city sewage, which is treated and cleaned by the Hyperion Water Reclamation Plant 3 miles away. 15%, or 40 million gallons of Hyperion's treated wastewater is diverted to our facility instead of being discharged into the ocean. This water had already undergone 2 stages of treatment, so when it comes to us, we start with a 3rd. This tertiary treatment can be a chemical reaction process done at the west part of the plant, or a physical removal of suspended solids in the water that's done at the east side of the plant.
Let's look at the chemical process first. It starts with the pre-treatment clarifier, where ferric chloride and a synthetic polymer are mixed with the incoming water. That looks like this. Ferric chloride is a type of liquid iron, really heavy stuff, and the synthetic polymer is a kind of glue. When combined, the polymer glues the dirty particles in the water to the heavy ferric chloride, and the resulting clumps sink to the bottom. This is called flocculation. After mixing, the flocculated water goes into a settling basin. The lighter material rises to the top and is skimmed off by a pipe. Water then flows through weirs and then down into our monomedia gravity filter, which is basically a charcoal filter. This is what the 12-foot deep basin looks like empty. The bottom is covered with a layer of anthracite coal. The water filters down through the coal and then travels to our final disinfection area. Here, it gets disinfected and then pumped out to the pipeline distribution system for irrigation and additional treatment.
This is great stuff for watering parks, highway medians, and corporate campuses, even for flushing toilets. Anytime you see purple pipes and purple signs like this, that's recycled water being used. We also send some of this water to a facility which treats it for use in industrial cooling towers.
The chlorination basin is covered by nearly 3,000 solar panels to help us power our facility. We don't waste any space, and we are mindful of our carbon footprint.
Now remember how the water coming into our facility got split into a chemical and a physical separation process? That's because some of our customers need water that's as pure as drinking water and has a lower mineral content. And for that, we treat it with advanced filtration techniques.
This basin is filled with arrays of microfiltration membranes. Each membrane is made up of thousands of hollow white fibers, like mini drinking straws. The fiber walls have microscopic holes 5,000 times smaller than a pinhole. Vacuum suction pulls wastewater through the holes. Dirt and bacteria are too large to fit, but water squeezes through. It comes out pretty clean, but we go even further. We then pass it through a reverse osmosis membrane, where the holes are 5 million times smaller than a pinhole. That filters out large molecules like those found in shampoos, pesticides, minerals, and heavy metals. Then we send it for disinfection with hydrogen peroxide and ultraviolet light. Comes out clean enough to drink. But it's used as seawater intrusion barrier to protect our groundwater basin. This is where water is injected along the coast to create a pressurized mound of fresh water that keeps the ocean from migrating inland and contaminating local groundwater supplies.
If we skip the disinfection step, the reverse osmosis water is perfect for use in low-pressure boilers, which are used in oil refineries. But that's just not good enough for high-pressure boilers, which are used in electricity production. They need ultra-pure feed water. So we run the water through reverse osmosis a second time, and we come out with a product that's just as pure as distilled water. So there you have it. 2 stages of purification before the water gets to us, chemical treatment and charcoal filtering to make irrigation water, more treatment in a separate facility to make cooling tower water, microfiltration and reverse osmosis for low-pressure boilers, additional disinfection for groundwater injection, and a second pass through reverse osmosis for high-pressure boilers. Whew! 5 types of designer water, all from recycled wastewater. What we do here is save drinking water for, well, drinking. And we provide industry with water that's even more pure than one of these. The Edward C. Little Water Recycling Facility is where we make fit-for-purpose custom water qualities. We're increasing capacity, expanding distribution pipelines, and adding customers. Together, we're helping to shape the future of water reuse. For more information,
Okay, that was a great video and a good break. Mr. Baez, do we have any questions?
We have one question here.
Okay.
From Jose. He wanted to know why do we have to disinfect the water?
That is,
I guess the water that we
yeah.
Why do we have to disinfect?
That's a great question, Jose. Well, we actually disinfect our irrigation grade water, or the water that is used to water grass at parks or at playing fields. And that's because, you know, sprinklers get really splashy. Sometimes people walk through sprinklers and sometimes it touches us. And we just want to make sure that in case it touches you or in case you accidentally get a little bit in your mouth or something, that it's perfectly safe for it to touch you. Now, the other type of water, the super clean water that we use to inject back underground is also disinfected, because that basically mixes with groundwater. And that's a type of fresh water or a freshwater resource that we all can access. It's how some of our cities and our water agencies, just like West Basin, dig deep, deep wells underground to get clean groundwater for us to drink. So that's why we disinfect it, because once we inject it back underground, it's going to mix around with the rest of the water there. And then eventually, in a few years, for example, we're going to drink it again. So we just want to make sure that this is treated wastewater. We want to disinfect it before it gets consumed or drank by people again.
We have one more question. Do you have time for another question?
Sure.
Just the question is, are the chemicals that are being used, are they safe for us?
Yeah, that's a great question. So I actually have some of the chemicals right here to show you also. So this is one of the chemicals that's added. It looks very dark. It's basically a liquid iron. Again, this is called ferric chloride. And then we have the glue that sticks onto all of the dirty stuff in the water. So this is the synthetic polymer. And this one, in my other hand, the dark one, is the ferric chloride. So we basically use these chemicals to grab onto all of these chunks in the dirty water. So I'm gonna try to get a little closer. So you can see that there's some floating chunks in the water right over there. So we basically add those chemicals to grab onto all of those dirty particles. We make it bigger and heavier so that it's easier for us to separate out and filter. So the chemicals are actually, they are not removed from, they do not stay in the water. So they actually get removed from the water recycling process. The purpose of these 2 chemicals are to make it easier to filter the water through tiny, tiny rocks or the coal that you saw earlier. And then all of these 2 chemicals are removed from that process. So it is safe to add because it is eventually removed in the end. And another chemical that we add is chlorine to disinfect the water, and that's perfectly safe. A lot of our tap water, a lot of the water in our swimming pools, for example, that has chlorine, and it's basically just a disinfectant that is safe to be in our drinking water in small amounts.
Thank you so much, Janelle.
Great. So I'll be moving on to my last section, which is a water filtration activity. And I just want to share that you don't have to be an engineer or a water recycling expert to be able to protect and save your drinking water in your homes and your communities. You can be a water recycling expert just by participating in this fun short activity that I'm going to show you. So we're going to do a water filtration activity really quickly, but if you're interested, you can copy this activity and do it all yourself. So I'll show you my materials. I have some dirty water. Nope, this is not poop or pee water that came from my toilet. This is just water that is mixed with some dirt from the outside, but we're gonna pretend that it's dirty water. So I also have a strainer. I have a funnel. I have some rocks. I have some clean cups right over here. I have different types of cloth, 4 different types of cloth actually. I have a sponge and I have a baster. So what we're gonna do is see if we can get this water and make it cleaner. So I want you all to think about different ways that we can use all of our materials at once or together in partnership so that we can get the water cleaner. So for example, I'm just gonna use the strainer and see if that helps to make our water a little cleaner. So I'm gonna put it up right in front of the screen or here. I'm just gonna do this right over here. So right over here, we have our dirty water. Remember, this is just water, tap water that's mixed with dirt. I'm gonna pour it over. So did that help to clean the water? Actually, not really. You can see in my little strainer, I got some bigger chunks out of the water, but then the water still has a lot of tiny stuff that we can't really see with our eyes or that can't really be removed from a strainer. So I'm gonna think about different ways that I can start using all of my materials together to get all of those smaller items out. So let's see, I'm gonna get another clean cup. What I think I can do is maybe we'll get one of these cloths. I'm gonna put it right over here. The reason why I'm getting these cloths is because I think they're gonna be really good at removing the smaller items out of this water because they have smaller holes than in the strainer. The strainer has pretty big holes so that all of the dirt can still pass through, but I'm hoping that these pieces of cloth can help catch all of the dirty stuff. So, and I'm also going to add maybe some rocks because we saw rocks in the video that I showed you earlier. So let's see if the rocks do play a role in cleaning this water. And to top it all off, I have a sponge, so why not use the sponge also? I can find my sponge. And here's my sponge. I'm going to put this sponge on top and see if that works to clean my water. So please note that I'm going to now be getting rid of this dirty cup and I'm gonna start using a clean cup because I don't want the dirty stuff in this cup to make my water dirty again. So I'm gonna transfer it over and I'm gonna start pouring slowly and carefully. So that's gonna take some time. So again, you all can be doing this at home. So see that it's literally just dripping. Oh, but now it's going a little bit faster. Okay, so we will stop it. So it looks like my water filtration activity worked. So remember, this is the dirty water that we started out with. And this is the clean water that we came with. So you can see that it's a lot cleaner, but you know, sometimes water needs to be filtered multiple times. You know, I don't know if some of your parents or your family members in your homes and your schools use like Brita filters to clean your water sometimes. You might need to do it twice. So I'm gonna start this process one more time and we'll see if we can get a cleaner type of water. So again, it's going through the sponge, it's going through 2 pieces of cloth and some rocks. So it got pretty clean. In the interest of time, I'm not going to do it again, but if I kept going, you can imagine how much cleaner this water would be. So we have this dirty water right over here. You can see, let me mix it around. So you can see that it still has a lot of dirt in it. It's not that clean at all. But then here's our cleaner water that we just filtered really quickly in less than 5 minutes. And we were able to remove all of those dirty stuff out. So a big difference just from filtering it through about 2 times. So again, if you want to try it again, I have seen some students get the water to be crystal clear, just the same as a bottle of drinking water, and it is possible. So if you're interested and if you want to start thinking about different ways that you can clean water or be a water engineer or a scientist, take a note of this screen or of my PowerPoint slide right over here, and you can try it with your family members at home. So again, some things to think about as you're doing this water filtration activity is, was it successful? I think mine was pretty successful, but I could go even further and clean it some more. How clean do we need the water to be? So this is similar to Delilah's question. Can we drink the water? And the answer is, technically the water can be clean enough to drink if you clean it well enough. So again, I would clean dirty water to different levels if I was going to use it for different purposes. So if I was washing my car, for example, maybe I wouldn't make the water as clean, but if the intention was to drink, cook, or shower with it, it means that we need to clean it even further. What will it be used for and who will be using it for? So same answer or same questions as the last one. Again, I wouldn't suggest that you drink this specific water that you're recycling, but at water recycling facilities, just like the Edward C. Little facility that I showed you earlier, it is possible. Were the materials clean? So like I said, I basically did the same process with these materials over and over again, but over time it's gonna get dirty. So if I kept doing it and if dirty stuff kept getting caught in my materials, I would have to clean it. And how often should this be done, or how many times should we do it? So those are all things to think about when you're recycling your water, or if you're taking wastewater and if you're turning it into clean fresh water. So I'm gonna end off with some additional activities that you can do at home to learn more about where your water comes from or the water cycle. So again, if you're interested, I believe this is shared with all of your teachers, so you can just go ahead and click on all of these links and participate with some of your family members also. So now I'll stop for questions.
Janelle, thank you so much. I think you answered all the questions that were being asked.
Okay.
You provided us with a lot of information on how to get the water as clean as possible to use. And we really thank you for your time and all your expertise that you shared with us today. So thank you so much.
Okay, thank you everyone for joining me today.
Teachers and students for being here with us. I want you guys to have a great day, and I hope that that you learned a lot today, okay? So thank you so much, and I know you'll be returning to class. Thank you.
Thank you.